Oh, welcome back, everybody. Yeah, you guessed it. Charles McFarlane is back in the house. Well, without further ado, I guess I shall introduce that Charles McFarlane is back this week, ladies and gents. I'm sure you're all upset by that. Good to see you, Charles. How was your trip this time? Oh, it's lovely. Great. I'm going to let Charles do today's lesson, so take it away, Charles. No, I don't want to do that. What? You know what? I'm going to let Nukes do the terribly boring review to start with. I'll do the new stuff. All right. Thank you for that, Charles. I guess I'll do a quick review with you from last lesson. We were talking about angles still. Here is a couple questions. I know the last worksheet we had was difficult. So let's go through a couple of questions like this. To start with, we've got two parallel lines. You can tell that they're parallel because they've got the arrowheads. And we do know that even though these lines, these transversals don't intersect and go all the way past, it still makes a bunch of equal angles in here. So I'm going to look for a Z shape to start with. There's the Z shape right there. So that means that this one has to be 59 degrees. And likewise, there's a Z shape here. So that has to be 68 degrees. So there's two easy angles, and just by knowing what we know what they are. Oh, that looks easy, Nukes. Indeed it is, Charles. All right, once you've got those two figured out, these must make a straight line at 180 degrees. So if I do 180 minus 59, that's going to be 121 degrees. And again, a straight line right here is 180 degrees minus 68 degrees. That's going to be 112 degrees. Oh, Nukes going to make that look easy. Hey, it's all practice, Charles. Practice makes perfect. Finally, we've got a straight line here. So if I take, again, this has to be 180 degrees. So 180 minus 59 and minus 68. And you will get, use your calculator, and you get a grand total of 53 degrees. So this one here has to be 53. Here's a supplementary angle down here. So it's 180 minus 25. It's going to be 55 degrees. Oh, Nukes, that's amazing. All right, here's kind of some of the stuff we talked about last day as well. We've got opposite angles here, so you know that, and you know this, and this. These ones over here, a little bit more difficult. Look for a straight line. There's a straight line right there, so that means this one and this one add together to make 180. So 180, take away 134. That means that this one's got to be 46 degrees. Now, right across from it has to be 46 degrees because it's an opposite angle. Charles, do you know what an opposite angle is? Oh, of course I do. And finally, the most difficult one here is this one right here. And you can look for a straight line. So here is a straight line. That means all three of those make 180 degrees. So I take 180. I subtract the two that I know, 46 and 66. Use your calculator. 180, take away 46, take away 66, 68 degrees. So that's got to be 68 degrees in there. And finally, we have a triangle, which we talked about last day, and we have something called a reflex angle. That's all the way around here. Oh, you want me to flex, do you, Nukes? No, I didn't say flex. I said reflex. So 265, if we take 360, subtract 265, leaves us with 95 degrees. That's got to be this inside angle. Well, it looks just about like a right angle. It's darn close to a right angle. Thank you for that, Charles. This is going to be 180 because this is a straight line, minus 135, 45 degrees. This one in here has got to be 45 degrees. That means this one's 45. That means this one's 135. And that means this one over here has to be 95 plus 45. That's 140 minus 180. This has got to be 40 degrees. In fact, we could also find this reflex angle because that's got to be 360 minus 40, which would be 320 degrees. All right, that's where we left off last day. New stuff for today is triangles. And here is where I turn it over to Charles McFarland to finish off today's lesson.
Oh, you just don't know what you're talking about, do you, Nukes? You want me to do all the hard work. All right, it looks like we've got some triangles here. Most of you know what a triangle is. It's a shape that has 3 sides. 3 is one of my favorite numbers, by the way. Looks like we've got a cute one. Isn't that cute? It's a cute triangle. It is cute. Look at that. It's beautiful. I'm not sure what a cute triangle is. I think it's just one that's pretty. I'm known some no, let's not even go there. I believe in a acute triangle, all the angles are smaller than 90 degrees. I'll even use the less than sign. I think it goes like that. Or is that greater than? I don't even know. Holy cow, Nukes. Is it that way or is it that way? I don't. I think it's that way. All angles are less than 90. Of course, in Scotland, the signs go the opposite way. All right, next we've got an obtuse triangle. I have no idea what that is. It looks to me like a really strange triangle. It looks to me like one giant angle. But it appears to be greater than 90 degrees. So one angle is bigger than 90. And it looks like we've got a right triangle. That is a triangle that's always right. It's never wrong. Ha ha ha. No, it is not a right. That sounds like my wife. She's always right. What? Oh, it must be because it's got a right angle in it. Holy cow. One right angle. Holy cow. I gotta figure this out as I go. So then we've got an acute, an obtuse, and a right triangle. I think a triangle might be named after me. All right, Nukes, what else have you got for us here? Oh my goodness, we've got more stuff. Holy cow. Scalene. That sounds like a girl I used to know. No, scalene. Oh, scalene. A scalene triangle. I think I know what that is. I think that's all sides are different. Kind of like my head. Scalene triangle, all sides are different, and all the angles are different too, I believe. So let's say all sides are different and the angles are different. Hopefully you know what diff stands for. I'll just put diff because I'm too lazy to put down different again. Then we've got equilateral triangle. Equilateral, it almost says what it is in the name. The lateral part of it, the sides of it are all equal. 3 equal sides and 3 equal angles. Kiddies at home, that is the key here because we're talking about angles. So 3 equal angles and they all must be 60. All 3 angles are 60. Notice it's got these cutesy little legs on it. It tells you that they are all equal sides and equal angles. And then finally, it looks like we've got a really strange word down here. That is not English. Isosceles. An isosceles triangle. Look at how cutesy it is. It's got 2 little circles in it. And two of my favorite little cute lines on it, aren't they cute? Two equal angles. All right, so these sides are equal in length, and at the bottom of it, the angles are indeed the same. Notice it has not got the same angle up here. That would be only for an equilateral triangle. Wow, I amaze myself sometimes. So two equal angles and two equal sides. So if you see a triangle that has these cutesy two little arms on them, you know that you've got equal sides and equal angles at the bottom. Take that, Nukes. All right, it looks like Nukes has drawn an upside-down triangle with two sides. It looks like a mouse. In fact, that used to be the shape of my body before I got overweight. I'm not sure what this drawing is for, but it looks like an isosceles triangle upside down. You will notice again that it's got two little arms, and therefore these little angles, which are marked with cute little X's, are indeed equal. I'm not sure what good that is, but let's try the next slide and see what happens. Oh my goodness, we've got almost the same thing. Oh, now we've got a number in it. It's got 80. All right, if this is 80 down here, I'm not sure what we're asked to find, but we could actually learn a lot from this triangle. Nukes has only given us one angle, and we could probably figure out all of the remaining angles. As we know, this one down here must be 80. I just learned that. And now I'm not sure how to figure out the rest. Can we find out the top, the little pointed area? Yes, we can. We know that everything's 180 in a triangle, and we subtract 80 and subtract 80, and that leaves us with 20. So this little dude is 20 degrees. You're not fooling me in it. Charles, before you move on, see if you can find the reflex angle on some of these, like this one and this one. Can you find the reflex angle for those? Oh, Nukes, you want me to flex again? Stop asking me to flex. No, Charles, I'm not asking you to flex. I'm asking if you can find the reflex angle once again. Remember how we did that? Oh, of course I do. We just talked about that. I take the 360 degrees and I subtract 80. I need a calculator for that, I think. Oh, no. I got it. It's 280 degrees as a reflex angle. That means that this one over here would also be 280. Very good, Charles. And the top one would be 360 minus the 20, 340 degrees. Oh, that Nukes, put that in your pipe and smoke it. Way to go, Charles. You got it. All right, so let's move on, shall we? What do you think of that, Charles? Oh, blimey, that's difficult. Holy cow. What am I supposed to do? I've only got the one top angle. I don't know where to start. Well, I know what the reflex angle is. That up there is going to be 360 minus 10. That'd be 350. Or as those crazy Brits say, 350. I think I'll take the triangle, which is 180 degrees, and subtract the 10 degrees, which I know, that leaves me with 170 degrees for these two equal angles. If they are equal and they make 170, if I divide it by 2, then that would tell me how much each equals angle is. Oh my goodness. I think that's going to be 85 degrees. Let's see if that works. I put 85 there and 85 there. Add those together, that's 170 plus 10 is 1. Oh, blimey, it's right. Those work. That adds up to 180. Spectacular. Oh, you're trying to fool me with the sideways one. You're not going to fool me that easy just because the isosceles triangle is laying on its side. It's still exactly the same rules. We've got two little arms there, that little cutesy arms. They're almost calling out to me. That tells me that these two down here must be the same. Even though it's on its side, you're not fooling me at all. Again, I'll take it 180. Subtract the 30, that leaves us with 150, according to my Scottish math that I did way back in the 60s. And then I'll divide that by 2, and that makes, holy cow, each of the side now is 75 degrees. Kiddies at home, don't forget to put your little degree sign. It's so cute making those little circles. In fact, that's so good, I want to do it one more time. Oh, that's so much fun. All right, what else have you got for us, Nukes? That's too easy. Oh. All right, that's where I have to go. I think I'll tap out here and leave this to you. I don't want to take all your time up. Nukes, I gotta go. I just got a phone call. I believe it. Hello. Yes, I'll be right there. Nukes, I'm out.
All right, Charles, thanks so much for your help today. We all, I'm sure, appreciate seeing you and hearing you once again. So hopefully we'll see you in the future. I'll take it over from here. Thank you. All right, I apologize for that, you guys. Although Charles was on his best behavior today, which is appreciative. Here we got, looks like some parallel lines. They're intersected with other line segments, and I do see an isosceles triangle in there thrown into the mix. That looks horrible. But we can sort it out. Let's do the easy stuff first. Let's put the opposite angles in. I'm not going to put degree signs in because I'm lazy. 110, we know that this is a straight line, which makes 180, so this has to be 70. Now remember that we just talked about, or what Charles just talked about, is that because this is an isosceles triangle, this bottom corner is also 70, and that is really key. Now, if those two are 70 and 70 is 140, the triangle itself, this whole triangle is 180. Those two make up 140, so that means this has to be 40 on top, and that fills in the triangle. Here's an opposite angle, we know that right away. And up here, we've got a supplementary angle. Those two add up to 180, so this has to be 140. So once we do some of the easy stuff, here is an alternate angle. That means this is 70. And here is supplementary angle. So this has to be 45 degrees again, because this one and this one adds to 180. And here we can make a Z shape up here. So that means that this is 45 degrees. This one has to be 45 degrees, that's opposite. This one has to be 7 degrees, that's opposite, 70, and this has to be 110 because it makes a straight line right here. So these two have to add to 180. Likewise, it makes a straight line right here. So these two have to add to 180, so that has to be 110. And also these are opposite of each other. All right, that leaves us with only, looks like one angle left, which, oh no, two angles left. We've got this one here, which is got to be 110. And finally, this guy right here. And there's two ways we can do this. We've got a straight line. So we could take 70 and 45 and subtract it from 180. Or we could use the big triangle down here, which also has 70 and 45 in the corners. So we could add those together. And what's that, 125? And then subtract that from 180 from the triangle. So 180 minus 75 added to 40, 70 added to 45, which is 125, and that leaves us with 55 degrees. So there we have it. We've now incorporated the isosceles triangle into one of the questions. So on your worksheet today, you're going to have some triangles and parallel lines and intersections and angles, and see if you can incorporate some of these triangles that Charles just talked about.